Namaste everyone, this is Sai Sri and welcome back to my channel. In this video, let us see how to simulate CB configuration, that is common base configuration, characteristics, input and output using Multisim. We also see the graphs of the input and output characteristics and also how to take the values using Excel sheet. Without any further delay, let's start the video. This video took me time to record, edit and give a voiceover. If it is informative and useful to you, please do subscribe, like, share to your friends. Firstly, let us place all the components required for the common base configuration. Firstly, we will simulate the input characteristics graphs and their values, and then we will see the output characteristics. Please do follow all the steps as shown. Make sure that your connections are correct while you are connecting the wires. Also see the terminals whether it is positive or negative. As we are going with the common base configuration, at the input we will use the positive is grounded and negative is connected to the resistor. So please do take this precaution while simulating this CB configuration input characteristics. I made the video as short as I can, so please do watch without any skipping any part. If not, you cannot get the output exactly how I got. Follow the same steps which I have done. So this is the complete circuit diagram of the common base configuration. Here you can see that the base is common for both input and output. Now in order to simulate it, click on Simulate, Analyze and then click on DC Sweep. Here you select Analyze Parameters So as we are connecting two sources, so give a tick mark to source 1 and source 2. Give the start and stop values and the increment values as shown, so that you will get the perfect graph. So as it is the input characteristics, we already know that the graph is between IE current in millivolts and voltage is VBE, nothing but the voltage between the base and the emitter, which we have connected. So we are going to take the values VA characteristics between VBE and IE at constant voltage VCB. So that's why I am selecting absolute IE, so that I can get the input characteristics. Now click on Run button. So this is the graph of the input characteristics of the CB configuration. Here you cannot differentiate at different VCB levels. That is nothing but at the different constant VCB levels, voltages. So here we cannot differentiate. So just maximize it so that you can see, or else you can also change the values. These lines are very near to each other, so I want to change the values so that you can get the exact one, or else you can make the R1 resistor as 0, so that the resistance offered will become 0, so that you can get the graph perfectly. So I am making the resistor value as 0. Now I simulate the circuit. So the same circuit will appear like this. So here you can see the difference, that is, now you can differentiate the different input characteristics. See, there is some gap between the lines. So here you can maximize, or you can select the graph area, whichever you require. So at constant VCB voltages, at some VCB voltage, I am getting one graph. So you can see that this looks like PN junction diode in forward bias. So after reaching certain voltage, they start giving the constant current, or they start increasing. So I am changing the name, the graph name, input characteristics of CB configuration. So as we all know that the graph is between the VBE voltage and current IE. I am also changing the x-axis and the y-axis also. So for the exact graph or the correct graph, I am selecting this region, so this looks like perfectly the input characteristics of the CB configuration. If you want the graph values, that is IE and VBE at constant VCB, you can click these three dots. so that an Excel sheet will be opened. There you can take some of the values required. So click on OK. You will get a number of values in the Excel sheet, but you have to take some values. So as the voltage is up to some millivolts, some range is very large, so select some values which are required for your table in the observation. So here you can find an Excel sheet at the bottom of your desktop. Please click on it. So an Excel sheet will be open. Here you can find the values of the input characteristics of CB configuration. These are input characteristics at CB constant, voltage CB constant. We are getting these values. So these are 3 values. You can get many values. So select starting from 100 Hz. 100. So start it from 100 voltage and then you can select 100, 500, 1000, and then from 1000 you can select 2000. So observe where there is a drastic change. There you take the value so that you can get only 20 to 30 values. Those are essential or sufficient for your observation. Regarding with these values, you can also take a graph using these Excel sheets. For this, you have to select both the voltages values and then select on insert. There you can find many charts. Select any chart which you required, any graph you required. So with these values, you will get the same graph which you got previously using this Multisim software. Now let us simulate the output characteristics of the CB configuration. For the CB configuration, you have to take constant VBE and you have to take graph between IC, that is collector current, and the voltage VCB at constant, remember, at constant VBE. For the input we will take VCB constant, for the output we will take VBE constant. So here we will select source 1 and source 2, and here we are taking the absolute value at current IC. So for the input characteristics we have taken the current IE, here we will take IC current as it is output characteristics, that is current IC. So here, in order to get the Excel sheet values, in bottom you can find many values. There you need to select VBE constant because we are taking the graph between the IC and the VCB. So take the values at VBE constant. Remember, VBE constant. So here also you get numerous values, but you have to select some. So the technique is first start with 100 H, take the value, or you can find a drastic change. Some drastic change will be found. So select the drastic change. So probably you can get 30 values. So minimize that values for your observation. Or else start taking the values from 100 H and then 500 and then 1000. From 1000 take the values from 2000, 4000, increment with 2000, and then you can take the values 10,000 to 20,000, 30,000, and then you can take it from 1 lakh and then 2 lakh and then 5 lakh, so that your values can be minimized.